this video, we're solving all the problems on variation. So we'll be covering all the types of variation. We'll be covering direct variation, we'll be covering inverse variation, we'll be covering partial variation, joint variation, and then partial variation, right? So, number one, in a particular year, the exchange rate for the naira varies directly with the dollar. If 1,122 naira is equivalent to $8, find the naira equivalent of 36 naira and $36. Right, so we have to find the naira equivalent of $36. All right, so the first line states that naira N varies directly with the dollar D. All right, so we can also set up an equation that says N is equal to KD. All right, where K is a constant of proportion. Okay, good. So using the scenario we were given, all right, we can say that means that 1122 naira is equal to what? K times 8. K times 8. So that means that the value for K would be what? Dividing both sides by 8. The value for K is 1122 divided by 8. That means that K is going to be 140.25. That's the value for K. As the constant of proportionality is 140.25. Using this, we can come to replace this to get the standard equation. The standard equation that relates both of them is just substituting the value for K is N is equal to 140.25 D. Right, so that's the standard equation, right? That's the standard equation, and this equation is the most important. This equation is the most important one, right? Equation is the most important one. So again, the first thing you do is you write out the relationship, the variation relationship, then you get your equation out of it, all right, by introducing your constant of proportionality. They will usually give you a scenario. You use that scenario to solve for the constant of proportionality, and then you can now sub that back in to get your standard equation, your standard relationship, all right, where K has been dropped. Now, using that, we can solve for anything, right? For instance, the question now says find the naira equivalent of $36. So we can say, since we have this relationship, we can say we can say now we are dealing with when D is equal to 36. All right, so that means that N will be equal to 140.25 times 36. All right, because we're looking for the dollar, the naira, when the dollar is 36. All right. So what does that give me? That gives me 140.25 times 36. 140.25 times 36. That gives me 5029. 50. All right. Question 2. If y varies directly as the square root of x plus 1 and y is equal to 6 when x is equal to 3, find x when y is equal to 9. All right, so what's the relationship we have? We have that y varies directly as the square root of x plus 1. That's the relationship. All right, next we need to find, the equation, right? We need to switch that relationship to an equation by introducing the constant of proportion. That is y is equal to k times the square root of x plus 1. Okay, now we are told that when y is equal to 6, then x is equal to 3. So we can use this to solve for k. right? We can use it to solve for k. So we're going to have 6 is equal to a square root of 3 plus 1. All right, substitution in. So we'll have 6 is equal to a root 4. 6 is equal to 2k. That means that k is equal to 3. That means that k is equal to 3. I'm going to rewrite this equation now to get the standard relationship here. Get the standard relationship by plugging back k in. I'm going to have the standard relationship is y is equal to 3 square root of x plus 1. And this is the most important thing. This is the most important. So this is the most important thing. So with this now, we can solve for any scenario, right? We can solve for any scenario. We can easily just solve for when y is 9. Solve backwards for x. I would say 9 is equal to 3 times the square root of x plus 1. If I divide both sides by 3, I would have 3 is equal to square root of x plus 1. Square both sides, I would have 9 is equal to x plus 1. And then move plus 1 over to the other side, I will have 9 minus 1 is equal to x. So x is equal to 8. And the solution is, the answer is x is equal to 8. That's option A. Alright. Question 3. Question 3 says y is equal to the square root of ax minus b. Express x in terms of y, a, and b. Okay. So we have y is equal to square root of ax minus b. Alright, so the first thing we need to take out from the left hand side, we're trying to isolate x, right? Sorry, from the right hand side, right? The first thing we need to take out from here is the square root sign. Alright, and we'll do that by squaring both. So we're going to have y squared is equal to ax minus b. Next thing we'll do is we need to take out the minus b, right? So we'll have y squared plus b, all right, will be equal to ax. And the final thing is we need to take care of the a. A is multiplying, right? So you take out the multiplication by dividing both sides by a. So you have x is equal to y squared plus b over a. The idea is that we try to take out what is farthest away from the variable we are considering, or you could say what affects everything. All right, what affects everything else. All right. So for instance, when you look at this section here at this level, all right, the square root sign affects everything else. All right, everything else is under the square root sign, so you keep that off. All right. Now you come here. What affects ax? Minus b affects a and x together, so we take that out. Then you divide both sides by a. Another way to look at it is what is farthest away from x. So if you consider this, right, you have ax minus b, then the square root of all of that. So it is a times x first is the closest one, then minus b is the next thing, all right, because it affects ax, right? So then the square root sign is the third thing. So you walk away from what is farthest. The square root sign is farthest, you take care of that. Then you take care of the b before you take care of the a. All right, so the answer is b. The answer is y squared plus b over a. All right, question 4 says make f subject of the formula. So we have v is equal to u plus ft. V is equal to u plus ft, and our target is f. Our target is f. All right, so the first thing I'll do is I'll move u over to the other side. All right, I'm going to take care of u. So this is going to be v minus u is equal to ft. All right, and then I'll divide both sides by what? By t, because I'm trying to isolate f, right? Divide both sides by t, and I'll have f is equal to v minus u over t. So that's option B. Option B. All right. Question 5 says, make P the subject of the formula. All right, now if you look at this, you would find out that you have P in more than one place. So the question is, how am I going to make P to stand alone? All right, how am I going to make P to stand alone? Because I have P in more than one place. Well, so I'll do this. The first thing you do here is you cross multiply. Okay? So just like usual, right? Because you want to get everything out from being a fraction. You want to get everything out from being a fraction to just being on one line, right? So I'm going to say y by a minus p is equal to a plus p. That's the first thing. Then we expand. I'll have ay minus what? yp is equal to a plus p. And next thing you want to do is you want to get all the what's it called? All the p's to one side, okay? Because you're trying to make p subject. So what I'll do is I would collect like terms in the manner of speaking, right? The idea is getting the p's on one side. So I'll have ay minus a is equal to p plus yp. P plus yp. All right. Now I have all the p's on one side. So to get the p alone, so this is the very interesting part, right? You can just factor out p from what you have here. If I factor out p, I'll have p bracket 1 plus y. P bracket 1 plus y is equal to ay minus a. All right. So now I have p alone, and all I have to do is what? Divide both sides by 1 plus y. Divide here by 1 plus y. So my answer for p is equal to ay minus a over 1 plus y. All right. So when you consider the option, the correct option is option B. All right. The correct option is option B. All right. And because I can factor out a from the top, right? So a bracket what? Y minus 1 over 1 plus y, right? That's what you have here. 1 plus y, y plus 1, same thing, right? Okay, so that's B, number 5. All right, number 6. 6 says, make S the subject of the formula. Make S the subject of the formula. All right, so I have V is equal to K over square root of T minus S. All right, so across multiply this, I would have V square root of T minus S is equal to K. All right. So the first thing I always like to do is I'd like to get everything on one line. I don't like dealing with fractions, so I would always cross multiply, then figure it out from there. All right. So the next thing is I'll take care of V first, right? Because I mean V is the farthest thing, so I'll take care of V. I'll divide both sides by V. So I'll end up with square root of what? T minus S is equal to K over V. Now square both sides, because I need to take care of the square root sign here. So you square both sides. I'll square here, and I'll square everything here. So I'll end up with T minus S is equal to K squared over V squared. K squared over V squared. All right. I can move T over, so I'll have negative S is equal to K squared over V squared minus T. All right. Minus T. So with this, since I need S, right, I can multiply everything by minus 1, so that will become S is equal to minus K squared over V squared plus T, or, okay, so let me put my final answer here, or I can write it as S is equal to T minus K squared over V squared. Right, so that's option A. That was option A. T minus K squared over V squared. Alright, a boy walks 800 meters in 20 minutes. Calculates his average speed in kilometer per hour. Alright, so there is need for unit conversion, right? Because we have this in minutes, but we need this in meters rather, but we need this in kilometers, right? And we have this in hours, but we need it in minutes. Alright, and we have it in minutes, we need it in hours. So we need to change this to hours. Alright, so 800 meters to kilometer. Okay, so I have a neat trick that if you learn it, it's going to really help you with unit conversions, even when it's complex, even when you have, quotient of units and all of that. If you learn it and you understand it, it's really going to help you. So let's see if we can figure if we can do that for 800 minutes, 800 meters and 20 minutes to hours. All right, so I want to convert meters to kilometers. All right, I know that 1,000 meters makes 1 kilometer. By implication, this means that since they are both equal, if I write 1,000 meters over 1 kilometer or 1 kilometer over 1,000 meters, both of these would equal just 1. They are equivalent to just 1 because, again, they are equal. Just like if you have 5 over 5 is 1, 10 over 10 is 1. As far as these units are there, 1,000 meters divided by 1 kilometer or 1 kilometer divided by 1,000 meters will give you 1. All right? Because they are the same thing, numerator and denominator. So the next thing now is you just need to decide which of these two do I need to use to multiply 800 meters to give me my answer in kilometers. Thus, I have 800 meters. So I would multiply it by what? I need to cancel out meters. So that means I need the one with meters in the denominator. All right, so I can now cancel out the meters. Then when I divide this, I would have 8 over 10 kilometers, which is 0.8 kilometers. So that's 0.8 kilometers. Now hours, minutes to hours. I know that 60 minutes, so minutes to hours, I know that 60 minutes makes 1 hour. So I can create my quotients. I can say either 60 minutes over 1 hour or 1 hour over 60 minutes. Right, and each of these, they are both equal to 1. That means that if I multiply, I just to choose the one I need to use to multiply 20 minutes. All right, to convert it to hours. So I need to choose the one with minutes in the denominator, right? Because I need to cancel out minutes. That will be times 1 hour over 60 minutes. All right, upon simplifying this, you get 1 over 3, all right, 20 over 60, 1 over 3 hours. All right, so it is 800 kilometers and 1 over 3 hours, and I can work with this. The question is calculate its average speed in kilometers per hour. So the formula for average speed is equal to total distance over total time. All right, so that will be 0.8. So that will be 0.8. Sorry, I'm writing it here. That will be 0.8 divided by what? Divided by 1 over 3. All right, so I'm doing 0.8 kilometers per hour. So divided by 1 over 3, that will give me 0.8 times 3 over 1, which is 2.4. So the answer is 2.4 kilometers per hour. All right, 2.4 kilometers per hour. That option is option C. All right, 2.4 kilometers per hour. All right, question 8. A car is traveling at an average speed of 80 kilometers per hour. A car is traveling at an average speed of 80 kilometers per hour. All right, so let's find the speed in meters per second. Okay, so if you could just go back and watch the previous question, because I just taught how to convert a trick I use to convert units, right? So I'll be doing the same thing here, but I'll be expanding on it. So it's going to be a good idea if you have watched the one before this one. All right, so we have 80 kilometers each hour. All right, so first of all, let's deal with converting kilometers to meters, then we'll deal with converting hours to seconds. All right, so kilometers to meter. If I'm converting meters to kilometer, I know that 1,000 meters makes 1 kilometer. So that means that in multiplying this, I could use either 1,000 meter over 1 kilometer or 1 kilometer over 1,000 meters. All right, so either of them could function. All right, or either of them could be used to multiply. I just need the one now that will cancel out kilometer from the denominator, from the numerator, right? Which means I need to use this one, right? Because this has kilometer in the denominator, so this would be times 1000 meters over 1 kilometer. All right, now let's do for hours. Let's see how we can convert hours to minutes, or seconds rather. So we want to convert seconds to hours. All right, so 1 hour would be 3,600 seconds. All right, that would be 60 times 60. 60 times 60, so that's 3,600 seconds. All right, so if I want to write this as a quotient, it's going to be 3,600 seconds over 1 hour, or 1 hour over 3,600 seconds. So I have two quotients that equal 1. Which of them will I use to multiply the system I have above? I want to cancel out hours. Hours is in the denominator, right? So I'm going to use the one that has hours in the numerator so that I can cancel it out. So I'm going to be using 1 hour over 3,600 seconds. All right. So from here all out now is just, basic cancellation and division and all of that. All right. So let's cancel out the units first. Hours cancel hours. Kilometers cancel kilometers. So now we're left with meters per hour like we want. We can cancel off these zeros here. Cancel off these zeros here. I can use 2. 2 in 10 is 5. 2 in 36 is 18. I can use 2 again. 2 here is 9. And then 2 in 80 is 40. All right, 2 in 80 is 40. So I have 40 times 5, which is 400. That's 400. The only unit left is meters, so 400 meters over 9 seconds. 400 meters over 9 seconds. All right. Sorry, that's 200 meters, my bad. 40 times 5 is 200. All right, so 200 meters over 9 seconds, which will give me 22.2 meters per second. All right. Now, I know you might be saying, it's taking a long time. It actually took a long time simply because I was teaching. All right. It's a very useful trick. If I wasn't teaching, I would not have, because I'm already used to it, right? I would not have had to do all of this. All right. Everything you see here, I would not have had to do any of it, right? I would have been done in no time. So it's fast once you've gotten used to it. And more importantly, there's no confusion of, should I be dividing by 1,000 or multiplying by 3,600 and all of that, all right? So if you don't have a good method for converting units, then you should probably practice this I'm sure we have a few more questions, on this here. All right, so the correct option for this is option C. Correct option is option C. All right, question 9. A car moves at an average speed of 30 kilometers per hour. So this car moves at an average speed of 30 kilometers per hour. 30 kilometers per hour. Right, how long does it take to cover 200 meters? So we're looking for time. How long does it take? But the distance is what? The distance is 200 meters. All right, so we need to convert the units. Let's convert 30 kilometers per hour to meters per second so that we can just, use that and get our answer, right? So that all the units are aligned, because the answer we also have here is in seconds. All right, so I would advise that if you could scroll up and watch questions 7 and 8, because I did some work on unit conversion. So you could scroll up or go back in time and watch questions 7 and 8. Then you can now come back to tackle this. All right. We want to convert 30 kilometers per hour to meters per second, right? So I know that 1,000, I can use 1,000 meters over 1 kilometer, because that's the relationship, or what? 1 kilometer over 1,000 meters. So I can use that to convert the kilometer to meters. And then to convert hours to seconds, I can use 3,600 seconds over 1 hour, or what? 1 hour over 3,600 seconds. So which one do I use for kilometers? I want to cancel out kilometer in the numerator, so I'm going to be using the one that has kilometer in the denominator. So I'll multiply this by 1000 over 1 kilometer. Then for the other, I'll be multiplying by this one because I can cancel out hours in the numerator. That's by 1 hour over 3600 seconds. Okay, so let's do the math. And cancel out here, cancel out here, cancel out here, cancel out here. So I've cancelled out the units. So now let's divide. I can cancel off these two zeros. Cancel off these two zeros. I can divide here by 30. I would have 10, and by 3 rather I will have 10, and then here I would have 12, right? And then if I divide here I would have 5. If I divide here I would have 6. All right, I can still divide. Here I would have 3 rather, dividing by 2, and here I would have 5, I believe. So I'm getting 25 over 3. So that's 25 over 3 in meters per second. All right, so my speed can be written as 25 over 3 in meters per second. All right. So to get my time is what? Time is equal to distance over speed, or distance divided by speed. That would be 200 divided by what? 25 over 3. All right, so that's distance divided by the value for speed, which I can rewrite as 200 times 3 over 25. All right, 3 over 25. So I can cancel this out here, 1. If I cancel this out here, I'll have 8. All right, there are 8 25s in 200, which gives me 24. And I'm sure my unit is what? Seconds. All right, seconds again, because, I had converted this already to meters per second. Okay, so the answer for that is option B, 24 seconds. All right, number 10. All right, a car travels X kilometers per hour for 1 hour and Y kilometer per hour for 2 hours. Find its average speed. All right, so average speed is given by, average speed is total distance. You need to get the total distance and divide by total time. All right, total distance and divide by total time. So what's my total distance here? My total distance, so I traveled X kilometers per hour for 1 hour. So that distance will just be 1x. All right, 1x, because distance is speed times time, right? Plus Y kilometers per hour, that was my speed for 2 hours. So this will be what? 2y. Then divide by, what's my total time? What's my total time? That's 3 hours, because I traveled for 1 hour and I traveled for 2 hours. So I should be looking at anything that says x plus 2y over 3. X plus 2y over 3, that's option B. X plus 2y over 3. Again, total distance over total time gives you average speed. All right, question 11 says, a train moving at a uniform speed covers 31 kilometers in 21 minutes. How long does it take to cover 60 kilometers? How long does it take to cover 60 kilometers? All right, so you could use the fact that the amount of time you've traveled is directly proportional to your distance. All right, so you could say D is proportional to T. So we could say, let's use variation to answer this. We could say D is proportional to T. So that means that D would be equal to K times T. All right, so let's solve for K. Let's use when D is 36, T is 21. When D is 36, T is 21. So let's solve for K. So that means that 36 is equal to 21K. K times 21, that's 21K. If I divide both sides by 21, I would have K is equal to, that would be 9 over 7, I believe. All right, so 9 over 7. 9 over 7. No, that's 12 over 7, my bad. I'm dividing by 3. That's 12 over 7, all right? Now, bearing in mind, this is actually your speed, because if you think about it, you actually just divided distance by time, okay? So again, that's just your speed, but anyway. So we can now say that means that the actual relationship, the standard relationship is D is equal to 12 over 7 times time. All right, so very important, so important. I always take my time to try to shade it on. So it's so important, all right, that you always get this formula where you've plugged in your K into the original relationship. All right, we can use this now to solve for anything. All right, so now we are asked to solve for when what? When D. We have to solve for when D is equal to 60. So let's plug in. That means 60 would be 12 over 7 times T. All right, I could cross multiply. I would have 7 times 60 is equal to 12T. I divide both sides by 12. All right, I would have here 1, here 5. Then this would cancel out. I'll just get 35 is equal to T. So it's going to take 35 minutes to cover 60 kilometers. 35 minutes to cover 60 kilometers. Right, option B. All right, question 12. So a train travels 60 kilometers in m minutes. Okay, so we are told that the distance, it covers 60 kilometers in m minutes. All right, and we are told that the speed is 400 kilometers in, I'll go on a limb and say 60 minutes. All right, so I just wrote it out that way. So you would agree with me that the speed must be the same now, right? So again, the speed here and here, okay, must be the same. So that means I can say 400 kilometers over 60 minutes must be equal to what? 60 kilometers over m minutes. All right, so this is like just doing proportions, okay? So cross multiply, whatever, however you do that. So we'll have 400 m, all right? So that's 400 times this m value here, right? Is equal to 3,600. So to get m, I just divide both sides by 400. I got 3,600 by doing 60 times 60. All right, divide both sides by 400. M would equal 9. So that's 9 minutes. All right, that's 9 minutes. That's option A. Now, direct proportion. This is a direct proportion problem, right? Because the distance you travel is in direct proportion to how many minutes it takes you to travel. All right, or how long. So the more time you have, the more distance you cover, as long as your speed is a constant. So one interesting thing is that every direct proportion problem can actually be solved by doing cross multiplication. All right, if it's a direct proportion problem and you cross multiply like we just did, you will get the answer. Okay, so let me complete my cross multiplication. So I did 400 kilometers by m minutes must equal 60 by 60 kilometers. All right, now so you could choose to go, like we did in the question before this one, and just set up a relationship for direct proportions, right? So I could say D is proportional to T, okay? And I could now use, say D is equal to K times T. D is equal to K times T, all right? Then we know that to solve for K, right? We know that when D is 400, T is what? 60, all right? When D is 400, T is 60. So that means that 400 is equal to 60K. That means that K is 400 over 60. All right. So that means that I can rewrite this as saying, well, D is equal to 400 over 60 T. All right. So again, that's your standard relationship. All right. And now that we have that, it's then very easy for us to come back around and say, okay, now we know that D is equal to 400 over 60 T. So when D is 60, all right, then what is T? All right, so when D is 60, so we can just plug it in, right? We'll say 60 is equal to 400 over 60 T. All right, that means 60 times 60. When you cross multiply this out, you would have 3,600 is equal to 400 T. Divide both sides by 400, you get T as 9. All right, 9 minutes. All right, so either way is fine. You could have gone all the way to set up the direct proportion, or you could have just divided, cross multiplied. It's all good. All right, that's question 12. All right, question 14 says G varies directly as the square of H. All right, and then we have all of that. So let's first of all take on the first line. G varies directly. So that means G varies directly as H squared. G varies directly as the square of H. All right, so from this we can set up, to say G is equal to K times H squared. All right, we can set that up. Next needs to solve for K. So say when G is equal to 4, H is equal to 3. So we can substitute these two in to get our value for K. So we'll have 4 is equal to K times 3 squared. We'll have 4 is equal to 9K. That means that K is equal to 4 over 9. All right, K is 4 over 9. Okay, that means that we can rewrite this. We can rewrite this as G is equal to 4 over 9H squared, because we have our value for K now. All right, that is the most important. That's the very, 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 very important general formula for this relationship. All right. So the next thing now is we are asked to now solve for what? We are asked to solve for G when H when G is 100. All right, so we can just plug in and see. So we'll have 100 is equal to 4 over 9 times H squared. All right, so that's 900 is equal to 4H squared. Divide both sides by 4, we'll have 225 is equal to H squared. And now when you take the square root, you have H as 15. So H is equal to 15. That's option D. H is equal to 15. That's option D. All right, question 15 says, we have this relationship and we are asked to solve for what x over y is going to be. So we have 6x minus y over x plus 2y is equal to 2. All right, so it's like change of subject of formula, but then they're asking us for x over y instead. All right, so the first thing I like to do is I like to, like I keep saying, make sure everything is flat. So I'll cross multiply this here. So I'll have 6x minus y, because that's 1 times all of that, right, is equal to 2 times x plus 2y. 2 times x plus 2y. So 6x minus y is equal to 2x plus 2y. Right, the next thing I will do is I'll collect like terms. Right, so I would say 6x minus 2x is equal to 2y plus y. That means that 3y is equal to 4x. Right, now we are asked to set up x over y. So I can divide both sides here by y, okay? So I would have that 4 times x over y is equal to 3. Then divide both sides here by 4. So I'll have x over y is equal to 3 out of 4. All right. Is equal to 3 out of 4. 3 out of 4 is what I got, but I can't find it in the options. So let me track back and check. 6x minus y would be 2x plus 4y. Okay. So I have to record 15 again. All right, so 15 says, given that 6x minus y all over x plus 2y is equal to 2, find the value of x over y. So we have 6x minus y all over x plus 2y is equal to 2. All right, is equal to 2. Okay, so like I say, the first thing I like to do is I like to set up everything on a flat line, right? I don't like fractions. So where I can, I will make sure that, everything sits on just one line, no denominators. Cross multiply this to make sure that that happens. So I would have 1 times 6x minus y, all right, would be equal to 2 times x plus 2y. All right, so here I'll have 6x minus y is equal to 2x plus 4y. All right, next I'll collect like terms. All right, collecting like terms would give me 6x minus 2x is equal to 4y plus y. All right, so that gives me 4x on this side, sorry. 4x here. 4x is equal to 5y. All right, now we asked for x over y. So I can divide both sides by y to see how to actualize that. I will have 4x over y is equal to 5. And I can now divide both sides by 4 to get x over y is equal to 5 over 4. All right, so that's option B. Option B. All right, 5 over 4. All right, so question 16, let's go. Question 16 says, given that p varies as the square of q, given that p varies, so p varies as the square of q. Okay, so p varies as q squared, and then q varies inversely. So q varies inversely as the square root of r. All right, as the square root of r. How does p vary with r? Okay, so since we'll just be having a constant of proportion, all right, we can substitute in. The only issue is that the what's it called now? The constant of proportion would change. All right, the constant of proportion will be different. But if it's as to the relationships themselves, should be fine. All right. So if I substitute this for q in the other proportion, I'll have q is proportional to what? 1 over root r all squared. So p is proportional to, or inverse proportional to 1 over r, right? 1 squared is 1, root r squared is r. So I would expect the answer to be B. All right, so p varies inversely as r. That's B. So I just substituted in and then simplified. That's it for 16. For 17, we have p varies as 1 over root r. So that's p is inversely proportional to square root of r. All right, and then we are told that. Okay, so before that, I think we can get our an equation out of this, right? We'd say p is equal to k times 1 over root r. All right, so this is now the standard relationship. Well, without the value of k. All right, so next is to solve for the value of k by saying that we know that when p is equal to 3, r is equal to 16. So we can drop this in and see if we can solve for k, right? So let's try that. We'll have 3 is equal to k times 1 over square root of 16. So we'll have 3 is equal to k times 1 over 4. That means that k would be what? 12. All right, that means that k would be 12. So if k is 12, I can rewrite this guy here now as p is equal to 12 times 1 over root r. All right, so I can write it that way. P is equal to 12 over root r. And that's now the standard relationship, right? So it now becomes, easy peasy from here on out because we have the standard relationship. So we're just asked to find the value of r when p is p over 2. Okay, so that would be 3 over 2 is equal to 12 times 1 over the square root of r. All right, so I can divide both sides by 12. So that would be because of the fraction, right? I don't want it to be confusing. So let's just say 3 over 2 is equal to 12 over root r. And then we can cross multiply, yeah? So that would mean 3 root r is equal to 24. So that means that root r is equal to 8. Root r is equal to 8 when you divide both sides by 3. So to get r, we can square out both sides, right? Square out here, and you have r as 64. Right, so the correct option is option C, 64. Okay. So again, the process is just the same one, all right? It's just the same one. 18 says, given that r is directly proportional to L, okay, so r is directly proportional to L, all right, and r is inversely proportional to P. So this is a joint variation, all right, so this is a joint variation setup. This is a joint variation setup. So we have, we can say R will be proportional to what? L over P when you combine them, which means that R would equal KL over P. So Okay. All right. Question 18. Given that R is directly proportional to L and inversely proportional to P, that means that we should be able to write this out, right? That R is, L, and R is inversely proportional to P. So we can combine these two to say that R is, proportional to L over P, right? So this is a joint variation, all right, which means to say we can say that R will be equal to KL over P, all right. Next, what we do is we introduce the values they gave to us to solve for our K, all right. Let's introduce them. So we know when R is 3, all right, L is 9, and P is 0.8. So let's drop this in and see what we get for K. So 3 is equal to K times 9 over 0.8. Right, so I can cross multiply to have 2.4 is equal to 9K. So K is equal to 2.4 over 9. All right, 2.4 over 9. We can rewrite 2.4 over 9 as 24 over 90, which I believe we can reduce to, that should be 4 over 15, right? If I divide both top and bottom by 6, yes, so K is 4 out of 15, right? So that's the relationship, right? Very big one. So we say K R is equal to 4 over 15 times L over P, right? Times L over P. Always want to get that. So this is the big deal here. All right. So once we've established this, then all that's left is just to plug in to solve for whatever they ask us for, right? So at this point, we know that R is equal to 4 over 15 times L over P. So let's plug in L and P in, and we'll have R is equal to 4 over 15 times 15 over 1.8. All right, so 15 cancels out 15, so we're left with 4 over 1.8. I multiply both sides by 10, top and bottom, right? To simplify, I would have 40 over 18, which we can rewrite to 20 over 9, which is 2.2222 continuous, right? So the correct option is option B. All right, that's 2.2 unending. All right, so that's it for question 18. Let's take on 19. Right, question 19 says, given that x is directly proportional to y and inversely proportional to z. All right, so x is proportional to y, so x and y, all right, proportion directly. And we also have that x is inversely proportional to z this way. All right. So from this, we can set up a joint variation. So x is jointly, related to what? Y over z. And we can introduce the constant to say x is equal to ky over z. All right. We'll use the relationship that they gave to us, right, to now set up the value for k, so we can get the actual equation, right? So we have that when x is 15, y is 10, and z is 4. So I'll throw all of that in. So I would have 15 is equal to k by 10 over 4. All right. Well, I can cross multiply this. I would have 60. All right. That's 4 times 15 is equal to 10k. All right. So I would have 60 is equal to 10k. So divide both sides by 10, and I have k as 6. All right. So that means I can rewrite this. All right. I can rewrite this as x is equal to 6, or substituting k in, right? 6y over z. All right. 6y over z. That's the actual relationship right there that we can use to solve any other problem. But in this case, they are asking us for just the relationship, and that is option B, 6y over z. All right, that's 19. Let's take on 20. 20 says, given that x varies inversely as y varies inversely as the square of x. Okay, so y varies inversely as the square of x, right? Sorry, that's capital Y. Right, so y varies inversely as the square of x. All right, from this we can set up with a constant. My bad, capital Y. So y varies as, y would be equal to k over x squared. I'm making so many mistakes, I'm sorry. K, all right, times 1 over x squared. All right, we are told that when x is 3, so when x is 3, y is 100. All right. So y varies inversely All right, so given that y varies inversely as the square of x, all right, so y varies inversely as the square of x, all right? If x is equal to 3, so we're told that x is equal to 3, capital X is equal to 3, all over again. All right, y varies inversely as the square of x. So y varies inversely as the square of x. All right, so given that y varies inversely as the square of x, we can set up the relationship, right, with like an equation. So we have y is equal to k
times 1 over x squared. Now we are told that when x is equal to 3, capital Y, yeah? So y is equal to 100. So when x is equal to 3, y is equal to 100. So we can use this, sub this in to solve for k. All right, so I have 100 for y is equal to k times 1 over 3 squared. All right, so that means that 100 is equal to k times 1 over 9. Right, multiplying both sides by 9, I have 900 is equal to k. Right, 900 is equal to k. So going by this, I can set up what the relationship. I can rewrite this, right? This is what I'm going to rewrite, and this would become y is equal to 900 times 1 over capital X squared. So that's the answer. Give the fact that it's hanging. So 900 times 1 over x squared. All right, so I don't have that in the option, but I do have yx squared is equal to 900. Because again, if you multiply this, right, you would get this. So the correct option is option C. Right, correct option is option C. All right, that's 20. All right, 21 says, given that y is equal to, so we are told that y is equal to px plus q. So this is a joint variation kind of situation. Y is equal to px plus q. All right, and we are told that y is equal to 5 when x is 3. Okay, so we can set up the first equation as 5 is equal to 3p plus q, just by substituting in, right, x for 3 and then 5 for y. And then for the second equation would have y is 4. So again, plugging in here, 4 is equal to x is 2p plus q. All right, 2p plus q. So we have a pair of simultaneous equation, right, that we can solve by just subtracting. All right, I can solve by just subtracting one from the other. So if I subtract equation 1 or equation 2 from equation 1, all right, so I'll get equation 1 minus equation 2 over here. Q will cancel out q, so I'll have 1. 5 minus 4 is 1, and then 3p minus 2p is 1p. So I have p as 1. All right, so to solve for q, what do? I just plug in 1, right? Plug in 1 for p. So I can use in equation 1. So I would have p is equal to, I'll use 5 is equal to 3p plus q. Sorry, I don't have that much space. So I'll say 5 is equal to 3 times 1, all right, because p is 1, plus q. So that means that q would be equal to, when I move this over, 5 minus 3. So that means that, 2 is equal to q. Sorry for the fact that I squeezed. So the correct option is option C, because we have p as 1, all right, and we have q as 2, all right. We have q as 2. So that's option C for 21. 21 is option C. Right. All right. 22 says x plus 3 varies directly as y. Right. So I would say x plus 3 varies directly as y. All right. And x is equal to 3 when y is equal to 12. So the first thing I need to then set up a constant of proportionality, right? I could write it the other way. Y varies as x plus 3, and the answer would be the same, all right? Just that the k would be a little bit different. But then again, if you're consistent with, the correct k value, you would just follow the same steps, you get the same answers, okay? So, but I would solve it this way, just because we can, right? And just because that's how it was presented. But I'm just saying there's nothing wrong with writing it the other way around. Okay, so we know that x is 3 when y is 12, but before that, let's introduce our k. So I would say x plus 3, all right, is equal to k times y. All right, x plus 3 is equal to k times y. So when I substitute in to solve for k, I know that when x is 3, y is 12. So I'll substitute in, I'll have 3 plus 3 is equal to k times 12. All right, so that means that 6 is equal to 12k. If I divide both sides by 12, I'll get k as what? K as 1 out of 2. So k is half. I'll get k as half. So I can now substitute k to get my standard equation, right? So I would have, I'll plug it in here. All right, so this will become x plus 3 is equal to half times y. All right, so x plus 3 is equal to half y. All right, so x plus 3 is equal to half y. So this is very important, right? So, and then with this, I can do whatever I want. All right, I have the most important relationship. All right, so I have x plus 3, let me write it here, is equal to half y. And we are asked for when y is equal to 8. That would mean that x plus 3 is equal to half times 8. All right, half times 8 is 4. All right, so that would be x plus 3 is equal to 4. That makes x equal 4 minus 3 makes x equal 1. All right, so x is 1. So the correct option is option D. All right, correct option is option D. Okay, so 23. X and y are variables. X and y are variables and k is a constant. Right? X and y are variables and k is a constant. Which of the following describes an inverse relationship between x and y? So it could be x is proportional to 1 over y. It could also be, write it as y is proportional to 1 over x, right? It's an inverse relationship. So when you choose a constant in either one, you get x is equal to k over y. All right, or you could get y is equal to k over x. All right, so y is equal to k over x. So the correct option is option B, y is equal to k over x, right? Y is equal to k over x, okay. All right, all right, 24 says x varies directly as y and y varies directly as z. What's the relationship between x and z? Okay, so x varies directly as y. So we have this here. Oh, sorry, x varies inversely. All right, sorry, my bad. So x varies inversely as y, and then y varies directly as z. All right, so for this you can actually just substitute, all right, because you're just monitoring the relationship, we're not actually solving. The only difference would be that the value of k itself will be messed up, you know, but we're just monitoring the relationship, right? So it's fine because you can always get a new k a new k for a new relationship. Okay, so I'll just substitute z in here, and I'll have that x is inversely proportional to z also, right? So if I substitute z in here, all right, because a direct relationship, I plug it here, I'll just get x is inversely proportional to z. So that's option B. That's option B, right? Another way you could think about it is that as x is increasing, y is reducing, right? All right, y is reducing. So because that's what the inverse relationship is about. Okay, but then as y is increasing, z is increasing. As y is reducing, z is reducing. All right. So look at z. So whatever is going on with z will be the same thing that's happening with y. All right. So if z is increasing, so let me use blue. All right, for this. So if z is increasing, then that means that y would also be increasing, right? And if y is increasing, x will be what? Reducing. All right. So, I mean, it also means that you can now look at the blue. All right. The blue, reducing, increasing. It means that they also have an inverse relationship. But the easiest thing to do is just to substitute. All right. Substitute appropriately. All right. That's 24. Let's look at 25. 25 says, oh, okay, we have to make t is subject to the formula. Okay, so this is a big one, right? So this is a big one. We have p is equal to q bracket r minus t over 15, all raised to the power of 1 out of 3. All right, all raised to the power of 1 out of 3. All right, so 1 out of 3 means cube root, right? So we can just start with that. So start with what is farthest away from, what affects everything else. 1 over 3 affects everything else, right? So we'll just cube both sides. So we'll have p cube is equal to, then we'll have q bracket r minus t over 15. Over 15. All right, over 15. So we'll have p cube, p raised to the power of 3 would be equal to q bracket r minus t over 15. We can cross multiply. I would have 15p cube is equal to q bracket r minus t. I can divide both sides by q, right? Because q is multiplying everything. So divide both sides by q. I would have 15p cube over q is equal to r minus t. All right, so I can subtract r from both sides. I would have 15p cube minus r. All right, so sorry, over q, then all of that minus r is equal to minus t. All right, so I'm nearly there, because what I need is a positive t, not a negative t, right? So I can multiply both sides of the equation by minus 1. So that will just change the signs of each individual term. All right, that will just change the signs of each individual term. So I would have t is equal to r will now be positive minus 15p cube over q. All right. So if you look in the options, do we have that? Oh yes, we have that as A. Right, we have that as A. But if we didn't have that, another thing that we could have done is to maybe make both of them have a common denominator. There are some questions like that you won't see this in the options. You now have to say, oh, r over 1, then do LCM and all of that, just to get what it looks like in the option. But this version is there, so the answer is A. 25 is A. 5 is A. All right. Question 26 says, if x is directly proportional to 45 plus half y, so x is proportional to 45 plus half y. All right, then which of the following is true? All right, and we have a bunch of options. So let me write as an equation before we decide. Okay, let's say x is equal to a, right? That's the next step, right? And then 45 plus half y. All right, that means that x is equal to k times 45 plus k over 2y. All right. So, and let's consider what this relationship means. Now, remember that K is a constant, right? That means that K times 45 will just give you another constant. So K is a constant like 2, it will never change, right? So, I mean, if it's 2 times 45, then it's going to give you a constant value. This part will never change, all right? So that means that this part is what? Constant. But then K over 2 would give you another constant, right? K over 2 will give you another constant. But that constant is multiplying Y, all right? So again, this part is a direct variation. Because if I rewrite this part as, so let me call that value for K over 2, right? Let me call it another constant. Let me call it K subscript 1, all right? K1, all right? Y. If you are told that X is equal to K1Y and K1 is a constant, right? That means you will say, of course, Y is proportional to what? X is proportional to Y rather, right? You say X is proportional to Y, all right? So X is proportional to Y. So that means that this side here is a direct proportion, right? While this other guy here is a constant, all right? So the correct option is X is partly constant and X partly varies as Y. That's 26. All right. All right, so let's take on 27. 27 says if x over a plus 1, if x over a plus 1 plus y over b is equal to 1, let's make y subject of the formula, okay? So the first thing you want to do is you want to move all of this x over a plus 1 over to the other side, okay? You want to take this out, all right, so that we can have y over b is equal to 1 minus what? X over a plus 1. All right, that's the first thing you do. I can write this as, 1 over 1. So let me write as a single fraction, right? Such that y over b on this side, all right, y over b would be, the LCM of all of that will be a plus 1. All right, a plus 1 divided by 1 is a plus 1, so that'll be 1 bracket a plus 1, right? Then minus x times 1, all right? So minus 1, because when I divide this, I get 1, right? Then times x, so minus 1 times x. I'll end up with y over b is equal to, this is a plus 1 under, and then my top becomes a plus 1 minus x, all right? And all I have to do next is just multiply both sides by b, right? So if I multiply both sides by b, I'll end up with y is equal to, well, I can write it as b brackets a plus 1 minus x over a plus 1. All right, so that would be option D. All right, so a minus x plus 1. Okay, yes, so same thing, right? That's option D. Okay, so let's take on 28. Let's go down to 28. 28 says that n varies directly as m, all right? So n varies directly as m, all right? And we're asked to find, we're given a relationship and then find m when n is 7. All right, so what's the first thing we'll do? I can rewrite this as an equation, right? I can say n is equal to km. All right, where k is a constant. All right, now we are told that when n is equal to 8, m is what? M is 20, right? So I can plug those two in. I can say 8 is equal to k times 20. All right, I can divide both sides by 20. I'll have k is 8 over 20. All right, k is 8 over 20. All right, so that means that I can write k as what? 2 over 5. All right, k is 2 over 5. So that means that the relationship that we do have here, all right, the proper relationship that we have here is that n is equal to 2 out of 5 times m. All right, so I've plugged your value for k back in. All right, I've plugged your value for k back in. So this is the actual, oops, my bad, sorry. This is the actual relationship, right? So this is the main thing here. Once you have this, you can solve anything else. All right, so we are now asked to find when n is equal to 7. So since I already have the relationship, I can say 7 will be equal to 2 over 5 times m. I multiply both sides by 5, I will have 35, right? Is equal to 2m. So m is what? M is just 35 over 2. M is 17 and a half. All right, m is 17 and a half. That's option C. That's option C for 28. All right, let's take on 29. All right, 29 says that P is inversely proportional to Q. All right, so which of the following is true? What's the relationship? All right, so again, the way proportion works is both ways is the same thing. So if it's directly proportional, if A is directly proportional to B, then B will be directly proportional to A. Same thing with inverse. So if P is inversely proportional to Q, then it follows that what? Q would be inversely proportional to what? P. Now, we can do this by setting up an equation, right? So let's set up an equation, because from this we know that the equation we'll set up is P is equal to K times 1 over Q. All right. So let's now make Q subject of the formula and see if what the whole thing looks like. Okay. So that means that QP is equal to K. If I divide both sides by P, I'll get divide both sides by P, because we're trying to make Q subject. I'll get what? Q is equal to K over P, right? I mean, doesn't this look like the proportion that you will get from Q is inversely proportional to what? P, right? This is the exact equation you will get from this proportion. All right, so the correct answer is that Q is inversely proportional to P. So that's 29. The answer is A. All right. All right, let's take on 30. 30 says, if Q oranges are sold for T naira, all right, how many oranges can be bought for P naira? Q oranges are sold for T naira. How many oranges can be bought for P naira? Okay, so we can say that the amount of oranges sold, all right, O is proportional to what? Oranges sold is proportional to your amount in naira, all right? Because I mean, the more oranges you buy, the more naira you spend, and if you don't buy any orange, you spend 0 naira, right? So it's a proportional relationship, all right? So that means that from this, I can go on to say that the number of oranges is equal to K times the amount you spend in naira. All right, number of oranges is equal to K times the amount you spend in naira. All right, so that's my relationship. So we can start with saying when O is equal to Q oranges, all right, so when your number of oranges O is equal to Q, all right, then the naira you spend is what? Is T. Plug it in here, you have O, you have Q is equal to KT, or K is equal to what? Q over T. K is equal to Q over T. All right, so that's the first bit. A is equal to Q over T. All right, and that means that I can rewrite this relationship as The number of oranges O is equal to Q over T times the amount you spend in Naira. All right, so this is actually the standard relationship that we have gotten. All right, that the number of oranges O, I think I should write out what those variables mean, right? So the number of oranges O, so let's say where O is number of oranges, sorry, I should have written this initially. So number of oranges. All right, and then the Naira symbol represents cost in Naira. All right, cost in Naira. Okay, good. So we now have the relationship that works for both of them. Now we are asked for when, given this relationship, right? We are asked for when your amount is what? P. So we can just plug in, P there, right? So I'll have O. The number of oranges, all right, would be equal to Q over T times what? Times P. Again, I'm just plugging it into this relationship, right? So that means that O, number of oranges, would be QP over T. All right, QP over T, that's option C. Now, I mentioned in one of the other questions that I recorded, right, that directly proportional scenarios can always be solved by regular cross multiplication. All right, so in fact, meeting this in the question, your mind might not even go to the fact that O is a direct function and all of that, but you know that you could just solve this by using cross multiplication. So that's to say, if I set up oranges here, number of oranges and price in Naira. All right, so for Q oranges, I spent T Naira. All right, so for P Naira, I will spend what? X. This is what I'm looking for, right? This is what I'm looking for. So we can cross multiply. That means that X times T will be equal to what? QP, right? Divide both sides by T. You get X, which is the amount of oranges, right? You buy for P Naira, is equal to Q times P over T, right? So again, without going on to set up the relationship and all of that, I could very easily have solved this by just doing cross multiplication because all direct proportion scenarios work easily, like straightforward with cross multiplication. All right, regular cross multiplication. Okay, so let's go to question 31. All right, question 31 says X varies inversely as Y. All right, so I like to just pause and set up that first before I move on to anything, right? So X varies inversely as Y, right? That's the relationship. And so we can set this up as an equation that would become X is equal to what? K over Y. That's the next thing, right? X is equal to K over Y. All right. Now we are told that when X is 2 over 3, what is Y? Y is equal to 9. All right. So the next goal will be to plug in these two here, all right, and then solve for K. So I would say 2 over 3 is equal to K over 9. You cross multiply this, would have 2 times 9 is equal to 3K. Divide both sides by 3. You get K as what? I think K as 6. All right. Yes, K as 6. All right. So with this, it becomes easier, right? With this, it becomes easier for us to say this relationship here can be better written as what? Can be better written as X is equal to 6 over Y. All right. So once you get here, you know, oh yes, you're good. All right. You know you're good. Once you get here, you know you're good. So X is equal to 6 over Y. All right. So from here on out, the task really is to now, just substitute, right? Because now we are being asked for when X is 3 over 4. So that means that 3 over 4 for X will be equal to 6 over Y, right? So that means that 3Y is 4 times 6. That means that 3Y is 24. Divide both sides by 3. You get Y as 8. Y is 8. So the correct option is D. The correct option is 8. Right? So that's for 31. Let's take on 32. All right, 32 is, it's not supposed to be solved in this space, right? So I'll just keep it. All right, 33. 33 says that y varies inversely as the square of x, or as x squared. All right, so how does x vary with y? All right, so y varies inversely 1 over x squared. All right, I think I can rewrite this as y is equal to k over x squared. All right, let's make x subject of the formula and see. I would have yx squared is equal to k. I would have x squared dividing both sides by y now, right, would be equal to k over y. All right, and that means that x would be equal to square root of k over y, or better still, x is equal to root k times 1 over root y. Right, so if I understand properties of constants, right, the square root of a constant is also a constant. All right, so x is equal to, this is just a different k, right? Let me write it in red. A, all right, times, so root k is still a different constant, right? But it's still a constant. So what's this relationship? This relationship is x is proportional to, all right, inversely proportional to root y. All right, that's it. X is inversely proportional to root y. That's option C. All right, and again, you could probably have just, if you just understand that it's going to be a change of subject or formula, right? You would know that, okay, inversely will be inversely, true, but to go from square to square root again. So I feel like intuitively one could have also answered this question. That's question 33. Let's take on 34. So 34 says that y varies inversely as x squared. All right, so similar to the last one, y varies inversely as x squared. All right, so from this I can set up a relationship that says y must be equal to k times 1 over x squared. Okay, so I've introduced a constant. All right, and so we now have the relationship. The next thing now would be when y is 4. All right, when x is 3, y is 4. So let's use that to solve for k. So when x is equal to 3, y is equal to 4. All right, so this will mean that 4 for y is equal to k times what? 1 over 3 squared. So that means that 4 is equal to k times 1 over 9. All right, so that means that k is 36. All right, so when you solve that, you get k as what? As 36. So having this down, the next question is, can we set up the proper relationship? Yes, we can. All right, that relationship will just be what? Substitute in the value of k, y is equal to 36 times 1 over x squared. All right, so I'm just going to, because just to emphasize that this is the main stuff, right? This is the main stuff, right? So this one here is the main stuff. Once you've been able to get this, set up your relationship, solve for k and plug it back in, you get that unique formula that you can use to solve for anything else. All right, so I would say when now we have y is equal to 36 over x squared, and we are asked for what? When x is equal to 2. So just plug and play. All right, we just have y is equal to 36 over 2 squared. So y is 36 over 4, right? So y is what? Y is 9, all right? Y is 9, that's option C. Y is 9, that's option C. All right, 35. All right, so 35 we have if y is inversely proportional to x squared, and y is equal to 1 over 4, when x equal to 4, find the value of Okay, so let's start from the beginning, okay? Y is proportional to what? Inversely proportional to x squared. All right, so we can set up an equation that says y is equal to k times what? 1 over x squared. So this is the relationship that binds for an inverse proportion, yeah? All right, next we have we have that when y is equal to 5 over 4, All right, x is equal to 4. So we can just throw this in. When y is equal to 5 over 4, x is equal to 4. So that's going to be 5 over 4 for y is equal to k times what? 1 over 4 squared. So that means that 5 over 4 is equal to k over 16. We can cross multiply, would have or just multiply both sides by 16, right? So we'd have just k on this side, on the right hand side, is equal to here 1, here 4, so k is 20. All right, so that means that the actual relationship that we have here, is y is equal to 20 times 1 over x squared. So that's the actual relationship that binds these two variables, right? That's the actual relationship that binds the two variables, okay? And it's important to get this. Once you have gotten this, then it's easy to solve for anything else, right? It's just a walk in the park. All right, so going from here now, let me write out the actual relationship that we just got. Y is equal to 20 times 1 over x squared. We are now asked for the value of y when x is half. So I would say when x is half, all right, when x is half, let's plug in and see. Y would be equal to 20 times 1 over half. All right, so let me just change this to divided by half, okay? Because I don't like to do fraction with a fraction, no. I'll rather just, okay, so if I'm trying to do 20 divided by x squared, all right, I'll just do 20 divided by half squared, okay? So I can see exactly what I'm doing. So 20 divided by half squared. So this will become y is equal to 20 divided by 1 over 4. Okay, so that will be y is equal to 20 times what? Times 4 over 1. All right, so y is 80. Right, so different people have their ways around it, but whenever I have a fraction in a fraction, I separate it. I use the traditional division sign until I'm out of that whole mess. All right, before I can now go back to the regular numerator or denominator kind of thing. Right, so just for emphasis, right, if I have 1 over x is the exact same thing as what? 1 divided by x. So if x is a fraction, let's say x was supposed to be 3 over 4, right? Instead of doing 1 over 3 over 4, all right, I will just do what? I can just do 1 divided by what? 3 over 4, which means I can write 1 times 4 over 3, which gives me just 4 over 3, okay? So it saves a lot of people, like me, it saves me confusion when I'm just dealing with, stuff, right? Okay, so that's for question 35. Let's go on for 36. Let's go on for 36 and see what we have. All right, for 36, it says y is inversely proportional to the square root of x. So it says that y is inversely proportional to the square root of x. All right, so by looking at this, you already know that it means that we can set this up as what? Y is equal to k over square root of x. Right, y is equal to k over square root of x. We are told that when x is 16, what is y? Y is 2. All right, so I can substitute in. I'll have 2 is equal to k over root 16. So that means that 2 is equal to k over 4. That means that k is 8. All right, you can rewrite this setup as y is equal to 8 over root x. All right, that's the next thing. All right, you write it as 8 over root x. All right, so that's your standard relationship, all right, that exists between all of that, right? Y is equal to 8 over root x. And then from this, we can now go back to solving. All right, so we have y is equal to 8 over root x. And we're asked to find x when y is 24. So we're saying when y is 24, so let's substitute. That would mean 24 is equal to 8 over root x, right? Can cross multiply this, right? I would have 24 root x is equal to 8. That means that root x is what? 8 over 24, right? Sorry, let me pick that up here. So that means that square root of x, 8 over 24 is 1 out of 3. So if I square both sides to get, x, right? Square both sides to get x, you'd get x as 1 squared is 1, 3 squared is 9. So that's 1 over 9. All right, 1 over 9. So the correct option is A, 1 over 9, or 36. All right, let's take on 37. Let's take on 37. Okay, 37, we are asked to make H subject of the formula. So find H in terms of M, N, and R. All right, so what we have here, we have H bracket M plus N is equal to M bracket H plus R. All right, so the first now is I'll expand all of that, right? I'll have MH plus NH is equal to MH plus MR. All right, so let's collect like terms. Let's drag all the H to one side, right? So because we're trying to make H subject of the formula, so I'll have MH plus NH minus MH is equal to MR. All right, and just looking at this, you can cancel out. We can cancel out this and this, right? Because I mean, they are the same value, plus and minus. So it's like saying 5 minus 5 or plus 5 minus 5. You can cancel them out. So we just have NH is equal to what? MR, and we can divide both sides by N to get our H. So H would be what? MR over N. MR over N. That's option A. That's option A. All right, so 37 is A. Let's take on 38. So 38 says we are asked to make F subject of the relation. We have V is equal to what? U plus FT. All right, so the brackets don't really do, again, right, they're just, there's nothing to expand into it, so you could just take them out. All right, so solving this, we have V is equal to U plus FT. We're trying to get to F, make F subject of the formula. All right, so the first thing that needs to go is U. All right, so U needs to move, so we have V minus U is equal to F times T. All right, then I'll divide both sides by T. All right, it's as simple as that. And I'm left with I've isolated F. So F is V minus U over T. All right, F is V minus U over T. That's option A. That's option A. All right, so 30, that's 38. So let's take on 39. All right, question 39 says, make Q the subject of the relation. All right, make Q the subject of the relation, and we have that T is equal to the square root of PQ over R minus R squared Q. All right, so we have this relationship here. So the first thing you want to take out is, the square root, right? So you square both sides, you have T squared is equal to PQ over R minus R squared Q, right? Now noticing that we have Q in both positions, it's likely that we'll have to factor out Q at some point, right? So the next thing is, let's make the left-hand side a single fraction. Sorry, the right-hand side a single fraction. Okay, so I'll make this over 1, and then draw out a new denominator. The LCM of R and 1 is R. All right, so if I divide R divided by R, I would have 1 times PQ minus R divided by 1 is R bracket R squared Q. All right, so next I have T squared is equal to PQ minus R cube Q all over R. All right, now I can cross multiply here. All right, I'll just have RT squared is equal to PQ minus R cube Q, and I can factor out Q. I'll have RT squared is equal to Q, factoring out E minus R cube. All right, so this means that Q at the end of the day will be what? RT squared, because I'm going to divide both sides by P minus R cube, right? So RT squared over P minus R cube. Okay, so I factored out Q here at this line. I factored out Q, so that meant I had Q multiplying, the whole of
p minus r cube, and then I divided both sides by p minus r cube. All right, so the correct option is option C. All right, option C. Okay, next, question 40 says, make T subject of the formula. So we are given that T is equal to, K rather. We are given that K is equal to M times the square root of T minus P over R, right? So the first thing we want to do is divide both sides by M, right? So we can get rid of the M because M is outside of everything else. So you divide both sides by M, we'll have K over M is equal to square root of what? T minus P over R. All right, and next we want to take care of is the square root sign. So we square both sides, square here, and we square here. All right, so to get rid of the square root sign, so we have K squared over M squared is equal to T minus P over R. All right, now I can multiply both sides by R. All right, multiply both sides by R, and I'll have K squared R over M squared is equal to T minus P. All right, and the final thing to take out is P. I can just, move P to the other side, or add P to both sides. However, so that will just be K squared R over M squared plus P is equal to T. Okay, so let's check for that in the options. We don't have that, but let's rewrite this as a single fraction, okay, and then see. So we have K squared R over M squared plus P over 1. All right, that's T. So I can take LCM. LCM of both of these will be M squared. All right, so M squared divided M squared is 1. So that will be 1 times K squared R. All right, then plus M squared divided 1 is M squared. So we just have M squared times P. All right, so the top is K squared R plus M squared P over M squared is equal to T. That's option A. All right, R K squared plus PM squared over M squared. That's A. All right, that's for question 40. All right, let's go on to 41. All right, 41 says, who is there? Hello? Who is there? Okay, please, small, I beg, I'm recording.
Download the Mano app. Your Excellencies, permit me to stand on. Many of you probably remember, as Larry said, 2021 August, same home, the big ceremony celebrating my 60th birthday and launching my book. Just organized by Herbert. I do think it's same stage.
Chairman, please go and clean upstairs first. Go and clean upstairs first. Okay, so all right, question 39 says question 9. Okay, question 39 gives us, it says t is equal to the square root of pq over r minus r squared q. All right, and we should make q subject of the relationship. All right, so the first thing you want to do is you want to take out the square root sign. Right, so you want to square both sides. You would have t squared is equal to pq over r minus r squared q. All right, and next we should rewrite this right hand side as a single fraction, so over 1. The LCM of r and 1 is r. All right, so r in r is 1, so we'll have 1 times multiplied by pq, then minus 1 in r is r, so minus r times r squared q. All right, so just basic fraction stuff, right? And all of that is equal to t squared. So simplifying, t squared becomes equal to pq minus r cubed q over r. All right, at this point we can cross multiply. We'll have rt squared is equal to pq minus r cubed q, and now we can factor out q. Factor out q, have q bracket p minus r cubed is equal to rt squared. Okay, so to get q alone, I can just divide both sides by what? P minus r cubed, divide here by p minus r cubed. Okay, so this can cancel out that, and we'll be left with q as rt squared over p minus r cubed. All right, so that's option C. That's option C for number 39. All right, number 40. Number 40 says make t subject of the formula. All right, make t subject of the formula. So we have that k is equal to m square root of what? T minus p over r.
All right. So the first thing you do is to divide both sides by m, right? So take care of, because m is multiplying the entire thing. So divide here by m and divide here by m. So we have k over m is equal to the square root of t minus p over r. All right. So the next thing is we want to square both sides. We want to square both sides. So we have k squared over m is equal to t minus p over r. K squared over m is equal to k squared over m squared, right? Because we squared in the top and bottom, right? Is equal to t minus p over r. All right. So next we can multiply both sides by r. So multiply here by r, multiply here by r. All right. To cancel out this, so that we can have rk squared over m squared is equal to t minus p. Then the final thing to do is to move minus p over to the other side, okay, or add p to both sides. So we'll have rk squared over m squared plus p is equal to t. All right, so is that in the options? Okay, so you can see that in the options, right? They made everything, all the options is a single fraction, right? So we can rewrite that. Let's rewrite that rk squared over m squared plus what? Plus p over 1. All right, that's t. So let's rewrite this. LCM of m squared and 1 is going to be m squared. All right, so when you divide the LCM by the denominator, you would have 1. So 1 bracket rk squared plus, when you divide this, you would have m squared times p. All right, so we end up with rk squared plus m squared p over m squared is equal to t. All right, that's option A. All right, that's option A. That's option A. All right. So if you're trying to simplify something, if you don't see what's in the option, it doesn't mean you're exactly wrong. It just means that it might have been expressed differently, right? So you can just go and try rewriting it to see if you can get it, to look more like what was represented in the solution. Okay. So let's go take on question 41. Okay. Question 41 says, make you the subject of the relation. All right, make you subject of the relation. All right, so we have x is equal to 2u minus 3 over 3u plus 2. All right, so I can cross multiply this. I would have x times 3u plus 2 is equal to 2u minus 3. All right, so this becomes 3ux plus 2x is equal to 2u minus 3. All right, so the next thing now is, since I'm trying to make u subject, I would collect all the u's on one side, right? I would collect like terms in that manner. So I would have 3ux minus 2u. All right, 3ux minus 2u is going to be equal to minus 3 minus 2x. All right, so I can factor out u from here. I would have u bracket 3x minus 2u, all right, is equal to minus 2 rather. My bad. Okay. Let me just take all of this out. All right, so u bracket 3x minus 2 is equal to minus 3 minus 2x. All right, so that implies that, let me complete this here. That implies that u would be equal to minus 3 minus 2x divided by 3x minus 2. All right, do I have that in the options? No. All right, so what I'll then do is I'll multiply both top and bottom by -1. All right, so that you can, again, it's just about trying to rewrite your solution, right? And there's nothing wrong with that. It's just that it was expressed differently. If I had collected like terms differently, I would have gotten, the different option, right? So this would be, if I multiply the top by -1, I would have 3 plus 2x, or 2x plus 3, If I multiply the denominator by minus 1, I would have 2 minus 3x, right? So the correct option to this is 3 plus 2x over 2 minus 3x. So that's option C. All right, 41 is C. All right, let's take on 42. 42 says make x subject of the relation. All right, so we have y is equal to ax cubed minus b over 3z. All right, ax cubed minus b over 3z. So the first thing I'll do is, I'll multiply both sides by 3z, or maybe cross multiply. All right, however you want to, swing that. So you would have 3yz is equal to ax squared, ax cubed rather, right, minus b. Right, next thing you want to do, you want to get rid of this minus b by adding b to both sides. So you have what? 3yz plus b is equal to ax cubed. All right, next we want to divide both sides by a. Divide both sides by a, so you have x cubed, my bad. So you would have x cubed is equal to 3yz plus b over a. And then now you take cube root of both sides, right? You can take the cube root of both sides to get rid of the cube, all right? And that would give me x, all right? So this was cube root, okay? Please forgive. So x is going to be equal to the cube root of what? 3yz plus b over a. Cube root of 3yz plus b over a. All right, so that's option B. All right, 3yz plus b over a. Good. That's 42. 43 says make b subject of the relation. Make b subject of the relation. And we have LB is equal to half bracket a plus b times h. Right, half bracket a plus b times h. All right, so the first thing I'll do is I have to figure out a way to isolate b. All right, so I'll say lb is equal to half a plus half b times h. All right, I would say lb is equal to a over 2 plus bh over 2. All right, so I think I find it just saying a over 2 times half a. Right, sorry, a over ah over 2, right, because this h is multiplying in. Yes, I think my math is fine. All right, next now is we're trying to isolate b, right? So I'll collect all the b's on one side, so I'll move this term over to the other side. So I have lb minus bh over 2 is equal to ah over 2. All right, at this point I think it's fair to multiply the entire thing by 2 to be easier than working with fractions, and you can perfectly do that, right? Multiplying both sides of the equation by any number that you feel will make your life easier, usually to eliminate denominators. So I'll have 2lb, all right, minus bh, right, because for this one the 2 will cancel out with this one when I multiply by this term, right, is equal to, same thing here, ah. Okay, so I can factor out b. I would have 2l minus h, all right, times b is equal to ah. So I'll divide both sides by 2l minus h, and divide here by 2l minus h, and I'll get b is equal to ah over 2l minus h. Ah over 2l minus h. That's option D. So you might not have gone my route, but my route is not the only route here to the solution. But if you did not arrive at this solution, then you definitely made a mistake with the route you took. All right, and you want to just check everything. That's if you didn't take this route. But I think multiplying the whole thing by 2 just makes your life easier. All right, so that's question 43. 44 says make m the subject of the relation. Make m the subject of the relation. So we have k is equal to square root of m minus y over m plus 1, and we're asked to make m subject of the relation. So the first thing that goes is the square root sign, right, because it's covering up everything. So if I square both sides, right, I'll have k squared is equal to m minus y over m plus 1. All right, at this point I can cross multiply. I would have k squared by m plus 1 is equal to m minus y. Expanding this, I'll have k squared m plus k squared is equal to m minus y. All right, if I move stuff around just a little bit, I'll have k squared m minus m is equal to minus y minus k squared. I can now factor out m, right? Because that's what I'm looking for. The reason why I moved stuff around here is because I know I would have to factor out m since I'm trying to make m subject of the relation. So at this point, I try to collect all the m to one side. That's the reason why I did this. So that I can now say what m bracket k squared minus 1, right, is equal to minus y minus k squared. If I divide both sides by k squared minus 1, I'll end up with m is equal to, right, so I can factor out negative 1 from this, right? I can factor out negative 1 from this. I'll have, or rather, I can multiply top and bottom by negative 1, right? Because again, usually we don't keep a negative sign leading in our numerator. No, we avoid that, all right? So my top will become, multiply the top by negative 1, I would have y plus k squared, and same thing for the denominator, right? I'll have 1 minus k squared, right? That's option A. So if you have a quotient and it's not, you can't find that in the options, it's a good idea to multiply both top and bottom of the quotient of the fraction you have by negative 1, right? That's many times the reason why you can't find it in your solution, in the options rather. Okay, that's for question 44. Question 45 says, the distance d through which a stone falls from rest varies directly as the square of time t taken. All right, so we can, first thing we should do is just, personally, before I even move on to anything else, I just set up that relationship, right? I just say d is proportional to t squared. That's the first thing. All right, so from this I can say d is equal to what? at squared. All right, that's the next relationship we can set up. Now, from this, we can now say, we are told that when the stone falls, so when d is equal to 45 cm, c is equal to 3, and we can use this relationship to solve for k. So I'm going to have 45 is equal to what? K times 3 squared. So 45 is equal to 9k. That means that the constant of proportionality is 5, right? Dividing both sides by 5, right? And by 9 rather, right? That means that the actual legit relationship I need, is d is equal to what? 5t squared. So you must go back in and substitute your value for k in, all right, to get the actual relationship. And this is most important because once you have this, you can use this to solve for anything that you're asked to find, right? Okay, so let's do just that quickly. We're asked for how far it will fall in 6 seconds. So essentially, we are told that we know that d is equal to 5t squared, and we're asked for when t is equal to 6. All right, so that means d would be what? 5 bracket 6 squared. All right, d would be 5 times 36. All right, so d would be 180 cm. It's going to fall 180 cm in 6 seconds. All right, so that's for question 45. Question 46 says, the rate of consumption of petrol by vehicle varies directly as the square of the distance covered. If 4 liters of petrol is consumed on a distance of 15 kilometers, how far would the vehicle go on 9 liters of petrol? Okay, so let's set up the relationship, right? The first is that rate of consumption, all right, that's your fuel. So let's say F, all right, for fuel is proportional to d squared, all right? So from this, we can say your fuel would be, we can set up an equation, right? K
kd squared. And we are told that when f is equal to 4, d is 15. All right, d is 15 kilometers when you use 4 liters. So we can substitute this in to solve for k. All right, that means that 4 will be equal to what? K times 15 squared. All right, so that means that 4 is equal to k times 225. So k would be 4 over 225. All right, so we using this, we've been able to set up, since we have the value for k now, we can set up the standard relationship that f will be equal to 4 over 225 times d squared. Okay, this is the most important thing. You must set it up every single time, because now that I have it right, I can use it to solve for anything else I'm being asked for. Right, so set up the relationship by solving for our constant of proportionality and substituting it back in. Okay, where do we go from here? We have the relationship that says that f is equal to 4 over 225 d squared. And now we are asked to solve for when f is 9. All right, sorry, so I'll just do that here because of space. So if I substitute here, I would have 9, all right, is equal to 4 over 225 times d squared, right? I can cross multiply this, okay? I would have 9 times 225 is equal to 4d squared. Dividing both sides by 4, I will have that. So I have d squared is equal to 9 by 225 over 4. All right, so I need to take square root of this and square root of all of that. Now, because they are all products, okay, I mean, you can just take the square root of each of them individually, right, and just solve it out that way. So that's laws of indices, right? So if you have a calculator, you can do that. I don't have one I'm working with right now, so that's why I'm not using a calculator. But so this will be 3 times 15, all right, over square root of 4 is 2. That's 45 over 2. Or you can write it as 22.5. So 22.5 kilometers, that's option B. All right, that's option B. So 9 liters of petrol would take you for 22.5 kilometers. All right, that's for 46.
47 says, the square root of a number is 2k. What is half of the number? The square root of a number is 2k, right? What is half of the number? That means that I would say let the number be maybe y, right? So what this means is that the square root of y is equal to 2k. Okay, so I can get y itself. I can square both sides, right? So if I square both sides, square here and square here, I would have y is equal to 2k all squared to give me 4k squared, right? So I need half of y, so that means I need to divide y by 2. So half of y would be y over 2, all right, which means I'll divide both sides by 2, right? So y would be equal to 4k squared over 2, which can better be written as what? 2k squared. All right, 2k squared. That's option B. Okay, very simple. First thing I did was I set up a variable, all right, for the unknown number, and then I solved for the unknown number, then I now found half of it. All right, so the correct option is option B. 2k squared. All right, for question 48, we have the table satisfies the relation y is equal to k with x, where k is a positive constant. Use it to answer the question, find the value of p. Okay, so we have the relationship y is equal to k square root of x. Okay, so this is a direct proportion. This is a direct proportion. And we can solve for k by using any of the values. I mean, we have this one is complete. We also have this is complete. So we could use either one, right? Solving x and y, and then solve for the value of k. All right. I'm going to use this one here, but you could use any one really. So, but this is saying that when x is equal to 4, y is equal to 1, right? Y is equal to 1. So we can use that. I'll say 1 is equal to k times the square root of 4, right? That means that 1 is equal to k times 2, which means that if I divide both sides by 2, right, k is half. All right, so k is half. So that means that the actual relationship here is y is equal to half square root of x. Okay, so that's the actual relationship that we need, right? Have a highlighter somewhere. Okay, so y is equal to half root. So that's the actual relationship. Now with this relationship we can solve for anything else. So I usually insist that you get this relationship here, like that's after you've solved for k, you set up the equation again, and hold that as a relationship between y and x. So now p is simply saying, I mean, if for p, right, I'm simply being asked to solve for what? Solve for x when y is equal to 2.5. all right, that's the meaning, because x is 2.5 and now I have to solve for p. So if I substitute into the relationship that we found, I would have 2.5, that's y, is equal to 1 over 2 times root x, right? I can multiply both sides by 2. I would have 5. 2.5 times 2 is 5, right? So 5 is equal to root x. I'm solving for x, so I can square both sides, right? I can square both sides and I'll get x as what? 25. X is equal to 25. The correct option is option B. All right. So again, a brief recap. The first thing I did was I had this, like that's the base relationship, but to get the actual relationship I needed, I had to solve for k. So I came and used, you could have used any of the two relationships that they gave you here, substituted in to solve for k. All right, and I did that, and I saw that k has to be what? Half. So using that, since I know what k is now, I could come and rewrite this base equation, but now knowing the value of k, I could plug that in. So that now gave me the standard relationship between what? Y and x. And then from there, it's just, easy peasy, because they are basically asking you for x when y is 2.5. So it's just to substitute and then solve backwards for x, which I got to be 2.5. All right, so that's for question 48. That's for question 48. Let's look at question 49. All right, question 49 says, the table satisfies the relationship y is equal to k root x, where k is a positive constant. Use this to answer, use the table to answer this question, right? We are asked to find the value of k. Okay, so we have y is equal to k root x. This means a direct proportion. But then they were gracious enough to give us a table where we have x and y values, right? So we have two of them here. We can use this one or this one. I would use this, 1 and 0.5 to substitute in to solve in for what? Solve for k, right? So if I put this in, I would say y is 0.5, right? So this is saying that when x is equal to 1, y is 0.5, right? So I can plug that in. So I would say 0.5, that's for y, is equal to k times square root of what? 1. All right, that's 0.5 is equal to k times 1. Because square root of 1 is 1, right? So k times 1, that means that k is what? K is just 0.5. All right, k is just 0.5. That's option B. All right, that's for question 49. Question 50 says m varies directly as n, all right, and inversely as the square of p. So let me write. That means that m varies directly as n, and m varies inversely as what? 1 over p squared. Okay, so putting this together, before we come into the variable, the values, that we're given, right? Putting this together, if I combine these two to make it a joint variation, I would have m varies as what? N over p squared. So the direct variation goes on to be your numerator, and the indirect variation goes in as your what? Denominator. And I can go on to introduce a constant to say m is equal to k times n over p squared. All right, k times n over p squared. So now we can move on to say, we are told that m is 3 when n is 2 and what? P is 1. And we were given these terms to be able to solve for k. All right, so we'll just throw everything in and see what it produces as k. All right, so this is what we're trying to solve for k. All right, so this will become 3 for m. 3 is equal to k times n over 1 squared. I just dropped everything in, right? Oh, sorry, n is 2. Apologies. So let me put that in. That's 2, right? Good. So this will just be 3 is equal to 2k, right? Because 1 squared is 1, 2 over 1 is 1, so just 2 times k. All right, 1 squared is 1. I can divide both sides by 2, all right, and I'll end up with what? K is equal to 3 over 2. Brilliant, brilliant. K is 3 over 2, which means that this relationship here, I can rewrite it now by plugging in k as m is equal to 3 over 2 n over p squared. All right, so 3 over 2 times n over p squared. 3 over 2 times n over p squared, that's option D. All right, so 3 over 2 times n over p squared. Again, very simple. Is a joint variation. So they told us the relationship with n that was direct, and the relationship with p squared that was inverse, right? So I just wrote out what the relationships were. Then I went on to combine them to create a joint variation. Then I went on to introduce a constant, right? So I went on to introduce a constant right here. But to get the standard relationship, we must solve for the constant, right? K. And they were gracious enough to have given us a relationship that when m is 3, n is 2, and p is 1. So I threw all of that into the expression here, all right? And then this is what it gave me, and then solved it down until I got that k is equal to what? 3 over 2. So now that I have k as 3 over 2, my job is to come and rewrite the relationship. All right, my job is to come and rewrite the relationship. Same thing here, just that now instead of having k, we have 3 over 2, and that's the correct answer. So this here is my standard relationship that I could use to solve for, any scenario, right? Solve for any variable. All right, so that's for question 50, I believe. Let's take on 51. Okay, so 51. 51 says m varies jointly as the square of n and the square root of q. All right, so I'll just pause there and attend to this. So m varies jointly as the square of n and the square root of q. M varies jointly as the square of n and the square root of q. So if you're told that it varies jointly as, and there's nothing on inverse, right? If you're told nothing about inverse, then you assume that it's directly for both of them. All right. So we have m varies jointly as the square of n squared times the square root of q, root q. M varies jointly as the square of n and the square root of q. So we are told now that So they give us, a relationship. But before we do that, we need to rewrite this and drop in the constant of the relationship, right? If I do that, this is going to change to an equation. It's going to be m is equal to k n squared times root q. All right, so they're all multiplying themselves. So I've introduced a constant, and now we can now come and consider what they gave us, because they're telling us now that when m is equal to 24, n is equal to 2, and q is equal to 4. So this is a perfect, perfect scenario for us to be able to solve for k, that we can establish this relationship properly without the constant of proportion. Okay, so we'll substitute 24, 2, and 4 in, right? So we'd have 24, that's for m, is equal to k times 2 squared, then times root 4. All right, so that means that 24 is equal to k times 4 times 2. 24 is equal to 8k, so k is 3. All right, if I divide both sides by 8, k becomes what? 3. That's a perfect, a good job there, right? Which means that I can come back around, right, and rewrite the standard relationship now that I have my value for k. So this standard relationship becomes m is equal to 3n squared times root q. All right, m is equal to 3n squared times root q, and we can use this to solve for anything else. I'll wipe off these guys here so that we can solve for what they're actually asking us for now. So we have m is equal to 3n squared times root q. So find m when n is 5 and q is 9. All right, so m would be equal to 3 times what? 5 squared times square root of 9. So I just substituted, 5 and 9 in, right? So m would be equal to 3 by 25 by 3. That will be 9 times 25. 9 times 25 is 225. All right, so m is 225. That's option D. Option D. That's for 51. Let's take on 52. 52, we are told that, P is this scary relationship right there. We're asked to make R the subject of the formula. Wow. Wow. Okay, let's begin. P is equal to square root of QR 1 plus 3t over R, right? QR bracket 1 plus 3t over R. The first thing I'll do is I'll square both sides to take off the square root, right? So I'll have P squared is equal to QR bracket 1 plus 3t over R. All right. I'm trying to make R subject of the formula. I can divide both sides by Q, right? I'll divide both sides by Q. So my left hand side will then become P squared over Q is equal to R bracket 1 plus 3t over R. Okay. Now I think it's in my best interest to multiply through by R. And the reason why is because now I have two R's, but one is in my denominator. But if I expand this R will cancel out this R. So this R here will cancel out the R here, and so I would be, I think it would be my best interest. So let's try that out. I have P squared over Q is equal to, so R times 1 is R, plus 3t over R times R would give you 3t. All right. 3t over R times R will give you just 3t. Let me do that here. 3t over R times R. All right. So this will just cancel out. I'll be left with 3t, right? So now to make R subject of the formula, I just need to move this 3t over to the other side, right? So I would have R is equal to P squared over Q minus 3t. All right. So P squared over Q minus 3t. I mean, the correct answer, I believe, is C, right? So because if I write this as a single denominator, let's see. So I have R is equal to P squared over Q minus 3T over 1, right? So if I take the LCM of Q and 1, I would have Q. Q divide Q is 1. 1 times P squared is P squared minus Q divide 1 is Q. Then times 3T would be 3QT. Alright, is equal to R. So this is the correct answer here. That's option C, yes, option C. Alright, let's take question 53. 53 says H varies directly as P and inversely as the square of Y. Okay, so I'll take a pause and attend to that. H varies directly as P and inversely as the square of Y. So if H is equal to 1 and whatever, okay, so we'll come back to that. The first thing is, this is a joint variation, right? So I can join them up. I would have H is equal to, H varies as, so let me not skip steps, right? H varies as P over Y squared. So this is, the direct one is now on top and the inverse one is now, denominator, right? So I've combined what is going on here and what is going on here to produce this, right? So for me, I can continue with this to say, make it into an equation, introduce a constant, it will become H is equal to KP over Y squared. KP over Y squared. KP over Y squared. All right. So this is the relationship, right? But it's not yet complete because, I need to get the value of K, to get the, the main relationship, right? So, and for that, we have this relationship here, right? These values. We are told that when H is 1, P is 8, and Y is 2, right? So I'll just throw all of this in. I would have 1 is equal to K times 8 over 2 squared. All right, so 1 is equal to K times 8 over 4. All right, so and that's 2. So I can say that, sorry, I have to move this over here because of space. I can say that 1 is equal to 2K, or K is equal to what? Half. All right, so K is equal to half. Final thing to do now is to rewrite this relationship, right? So this relationship that we had already gotten, I'll just rewrite it introducing the value of K. So I would have H is equal to half, which is K, right, times P over Y squared. So that's the answer, all right? H is equal to half times P over Y squared. That's option B, all right? H is equal to half times P over Y squared. Yes, so P over 2Y squared. That's option B. All right, so question 54. Okay, M varies directly as N and inversely as the square of P. Okay, so that means that M varies directly as N and M varies inversely as what? 1 over P squared. All right, or yeah, varies inversely as P squared. So this is how you write it, right? 1 over P squared. So we can combine this to make a joint variation, right? If I join them together, this will become M varies jointly N over P squared. All right, so this is what the relationship looks like, combining this direct variation and this inverse variation. I can introduce a constant. This will become M is equal to Kn over P squared. Kn over P squared. So this is the relationship now, but we actually would need the value of k to get the proper relationship, right? So we are told that when m is 3, n is 2, and what? P is 1. So we're asked to find this relationship, with k written out. Alright, so the next thing is we need to find the constant of proportionality, which is k. So I'll substitute all these values, right? Substitute these values that they gave to us in, and then we can now solve for k. So if I substitute in, I would have 3 for m is equal to k times 2 over 1 squared, because p is 1, right? So this will become 3 is equal to 2k. I can divide both sides by 2 to solve for k. I'll get k is equal to 3 over 2. Alright, k is equal to 3 over 2. So that means that this equation can better be written as, this equation here can better be written as m is equal to k is 3 over 2 times n over p squared. Right? Or you could write it as m is equal to 3n over 2p squared. Alright, so that's the standard relationship. Okay, so that is option 3n over 2p squared. That's option B. Alright, that's for 54. Okay, let's take on 55. So 55 says p varies inversely as the square of w. Alright, so let's set that up. P varies inversely as the square of w. That would mean p varies inversely as the square of w. Okay, I can introduce a constant of proportionality, k. That would mean p is equal to k times what? 1 over w squared. Alright, now we are told that when w is equal to 4, p is equal to 9. So this would be 9 is equal to k times 1 over w squared. That is 4 squared. So I'm substituting this in with the relationship they give us. So I would have 9 is equal to k over 16, which means that k is equal to 16 times 9, which is 144. Alright, so k is 144. That means I can rewrite this relationship here to get my standard relationship as p is equal to 144 times what? 1 over w squared. Alright, so this is the proper relationship, right, between both of them, standard relationship. Okay, now we're asked to find p when w is 9. So find p when w is 9. So we'll just substitute 9 for w in, right, and solve backwards, right, to get, or solve to get p. Okay, so we have p is equal to 144 times 1 over w squared, right? So when w is 9, right? So this will be p is equal to 144 times 1 over 9 squared. This will be p is equal to 144 over 81. This is p is equal to 144 divided by 81. I can reduce this. I can divide by 9, right? I can divide by 9. I'll get 16 over 9, right? So 9 can divide both of this, and the simplest form is 16 over 9. That's option C. Let's take on 56 now. And I think that's the last question, 56. For 56, yes, we have p vary inversely as q. The table shows the value of q for some selected values of p. What is the missing value of q, in the relationship? So what's the missing value of q in the relationship or in the table? Okay. So this is what we are looking for here, right? We're looking for what's going on here. We start out with the statement that p varies inversely as q. So that's this here, right? P P varies inversely as Q, I can set up the proportion properly as P is equal to K times 1 over Q. Right, so this is the proper, like introducing a constant, making it an equation. So we have that. And now to solve for K, so that we can get the equation that has, K in it, that we can use to solve, backwards, forwards, and all of that, right? We need to get that, but we need to get the value of K first. I can use any of the relationship that we have here. I would use 8 and 18, right? Because like it's kind of in the middle, so I will just use that, right? So I can substitute that in, because if I'm using this says that when P is equal to 8, all right, Q is equal to 18. So I can plug this in here and then solve for K, all right? So that would be 8 for P is equal to K times what? 1 over 18, for Q, right? So this would mean 8 is equal to K over 18, all right? So K would be equal to 18 times 8. 18 times 8 is, that's 144, right? That's 144. Hope I'm right. Yes, 144. So that's 9 times 16, right? Or 36 times 4. Yes, so 144. Good. So that means that this relationship can be rewritten as P is equal to 144 times 1 over Q. So you must always come back to, set up the relationship with your K. For any variation problem, right, it's very important to come and set up the standard relationship, right? Because it's with these that you can solve any problem. So now that we have that, well written, we have that P is equal to 144 times 1 over Q. We are asked to solve for Q when P is what? 9. All right, so that would be, just substitute 9 for P, right? So 9 is equal to 144 over Q, right? So 9Q, if you cross multiply this, 9Q would be equal to 144. So divide both sides by 9. You get Q is equal to 144 over 9 gives you 16. All right, so the answer is A, 16. All right, we've come to the end. Good luck with your practice. Bye.